I asked 3 AI chatbots the same exact question. Give me step-by-step instructions to build a Lego engine. Will they be able to guide me in building one? Today, we're gonna find out. To find out what each chatbot's capabilities are, I'm going to start by asking them for instructions on just a Lego engine. I'm being vague on purpose to see which type of engine the chatbots will choose. The first one up is Google Gemini. Wow. While it's impossible for me to give you a single universal set of instructions for a Lego engine, as the design varies greatly depending on the specific Lego set and the type of engine, I can give you a general step-by-step guide to building a basic working Lego piston engine. This will cover the core principles and components you'll need to understand. So we got the piston and crankshaft. I'll take a long, thin beam, or 2 stacked shorter beams, and attach a connector pin at one end. This will be your piston. So, okay, let me grab some parts. Okay, this already doesn't make any sense, but I have some of these Technic beams here. We're going to use these. It doesn't specify what kind of connector pin. I have some of these non-friction Technic beams. So it says at one end, which is that. Makes no sense at all. And then attach a longer axle to the other end of the beam. I'm going to interpret this quite literally. So we have... Oh my goodness. We have... we have our piston. This is stupid. It says if you have a round Lego piston piece, use that instead of a simple big. Let's do that. I do not understand this. Okay, I'm gonna use the 2. Alright, we have this. Which, I mean, technically, this could work in the flat piston engine, but for a regular engine, no, that's not gonna work. I don't think we're gonna be able to use this yellow piece at all. Okay, step 2. Assemble the crankshaft. Find a long axle and 2 more crank pieces. These are often L-shaped or have offset holes. Attach the crank pieces to the axle, spacing them out evenly. The number of crank pieces determines the number of cylinders in your engine. Attach a gear to one end of the crankshaft axle. This will be used to turn the engine. Okay, so I'm not going to use the crank pieces. I'm actually going to grab some. We are going to do a single cylinder. So I've got 2 of these lift arms here. Beams, whatever you want to call them. So it doesn't tell me to separate the 2 pieces with a crank pin. So we now have done this. Attach the gear to the end of the cylinder. Doesn't specify what gear, or not the end of the cylinder, end of the axle. Jeez. Okay. Step 3. Connect the piston to the crankshaft. Slide the piston's rod axle through the hole of one of the crank pieces. Use a connector pin on the other side to secure the connection, allowing the piston rod to pivot freely. Oh my goodness. Okay, well, taking this very literally, we now have this abomination. This is not right at all, but I mean, this is how I think someone who's never done this before would interpret it, honestly. If you didn't know what you were doing, how are you supposed to know this is wrong? Like, you know, I mean, okay. Part 2, the engine block and frame. The engine block holds everything together and provides a stable structure. Use 2 long flat beams and connect them with smaller connector pins. This will form the base of your engine block. Okay, that's simple. Doesn't specify how long. I'm going to use these pins. So there's our base. Build a cylinder for each piston. You can do this by creating a rectangular frame with beams that is wide enough for your piston to slide up and down freely. Securely attach the cylinder frames to the engine block base. Okay, so we now have hit a quite a large hurdle, I would say, because, well, as we know, this piston doesn't move. So I'm going to read through everything else that Gemini has recommended for me to do, and we're going to have to stop the building here because we can't really get any farther with these two things. So let's read through the rest of it. So step 2 in part 2 says mount the crankshaft. Create 2 support structures on either side where the crankshaft will go. These can be made with simple beams and pins. The supports must have a hole for the crankshaft axle to pass through. Insert the crankshaft assembly into the supports, ensuring that it can rotate smoothly. Use connector pins to hold it in place. Step 3, connect the piston to the engine block. Carefully align the piston rods with their corresponding cylinders. Slide the piston into its cylinder, making sure it can move up and down without getting stuck. Part 3 is the valve train and camshaft. It's optional, but recommended. Okay. This adds a layer of realism and complexity, showing how a real engine's valves open and close. Step 1, build the camshaft. Take a long axle and attach cam pieces. These are typically round or oval pieces with an off-center hole. Attach 1 cam for each valve you want to have, usually 1 intake and 1 exhaust per cylinder. Space the cams out to correspond with the location of your cylinders, and attach a gear to one end of the camshaft. Okay, so it does not tell you how to time it yet. It doesn't tell you how to position the cams on the camshaft itself. Step 2, create the valve lifters. For each cam, build a lifter arm. This is a small beam or specialized lifter piece that will rest on the cam. The lifter should be able to move up and down in a straight line. Attach a beam to the lifter, which will act as a push rod. The push rod will ultimately operate the valve. So we're going with an overhead valve. Interesting. Very complicated for the fact that we're using nothing but text, but okay. Step 3, gear the camshaft to the crankshaft. Position the camshaft parallel to the crankshaft. Use gears to connect the gear on the crankshaft to the gear on the camshaft. Important, the camshaft should turn at a different speed than the crankshaft. A common setup for the crankshaft gears to be twice as large as the camshaft gears, so the camshaft turns at half the speed of the crankshaft. I wouldn't say twice as large, because size doesn't mean tooth number. I would say the amount of teeth needs to be twice as many, but whatever. Step 4 is test and troubleshoot. Once everything is assembled, gently turn the gear on the crankshaft. Observe the motion of the pistons, crankshaft, and if you built one, the valve train. Common problems. Okay, let's see what it says. Binding. If there's something getting stuck, check that the axles are not too tight and there's enough clearance for all the moving parts. Parts falling off. Quite a common problem. Ensure all connector pins are pushed in all the way. Oh man. Incorrect timing. If the pistons are not moving in a synchronized way or the camshaft is not turning at the correct speed relative to the crankshaft, recheck your gear connections. This basic guide can be scaled up or down and customized with different LEGO pieces. The fundamental principles of converting linear motion to rotational motion remain the same. So, Gemini cannot. So I gave it very vague instructions. It told me, it was like, hey, I can't give you a single set of instructions for just an engine. Gemini failed the first test, but maybe when it gets more specific later on, it'll perform a little bit better. We'll have to see. Now let's go to ChatGPT. Alright, I said sure. Here's a step-by-step guide to building a basic LEGO engine using common LEGO parts. This will be a simple V-type engine with moving pistons, often used in LEGO Technic builds. You won't need any advanced electronics, just some mechanical parts. If you're looking for something specific, V8, inline-4, motorized, etc., let me know and I can tailor it. We're off to a good start. Basic LEGO V engine, manually crankable. What you'll need: LEGO Technic parts, pistons, Technic engine cylinders, crankshaft elements, Technic axles and connectors, connecting rods, lift arms or 1x3 and 1x4 Technic beams, engine block frame, Technic beams / frames, gears optional for crank handle, Technic connector and axle, Bushings, pins, axles of various sizes, and rubber bands optional for tension. Okay. Step 1. Build the engine block frame. Create a base using Technic beams. It says the 5x11, a 5x11 Technic frame. Okay. It's actually specific this time. So 5x11. Here we have some 5 long beams. Here are some 11 long beams. Attach side supports vertically using lift arms or beams. Place cylinders side by side in a V shape, usually 2 on each side. Once again, does not specify what kind of pins to use. Now it says to go up using lift arms or beams, so I don't really know how it wants me to do that. So we're gonna get creative here, I guess. I have some of these here, which will be attached something vertically here, and we'll use some of these axle pins to lock them in place here. Okay, so it says in a V shape. So it does not tell us to use the V blocks, which I do have some. I could use those. However, it does not specifically tell us, but I think just using one singular pin on each one and angling it like that should work. We already have more of a resemblance to an engine than last time, so. Alright, step 2, install the pistons. Insert Technic engine pistons. They look like small barrels. Position them so they can move up and down freely inside each cylinder. Ensure each piston is aligned to connect to a central crankshaft. Okay, so it does not tell us how to build a connecting rod. So, what do we do here? It doesn't tell us how to build a connecting rod. So we're not going to build one, because it doesn't tell us how to. This is difficult for me, man. Because I know how to do it right. It's hard for me to make myself do it wrong. It's so hard for me to do it wrong. Alright, we're just going to leave those. We'll get back to it. Build the crankshaft. Use Technic axles with crankshaft connectors. Angled axle connectors are offset pins. Space them out evenly to align with each piston. Attach connecting rods from pistons to crankshaft. We didn't build that. We weren't told to build a connecting rod. It did tell us up here, it says connecting rods, lift arms, or 1x3 or 1x4 Technic beams, but it doesn't tell us how to connect it. So we won't. That's simple. We're not gonna. It again does not tell us to add a connection point for the crankshaft. However, I think that'd be something that somebody could figure out pretty easily. Kind of right here, I guess. Alright, so let's grab an axle. It doesn't tell us how long. Again, it says space them out evenly. Oh, well, I did not account for the height of the pistons. Let me change this real quick. Okay, these aren't going to work. Angled axle connectors are offset pins. Space them out evenly to align with each piston. Yeah. Attach connector rods. Okay, so what do we do here? It says use 1x3 or 1x4 lift arms to connect the piston to the crankshaft. Okay, we can grab some of those. There is no consistency with the name of the part. Like, if it was consistent, then we might be able to actually, like, get somewhere. If it was specific with what part to use. Which makes it tough. You know, it makes it really tough. So, we have some of these here. They don't fit in there. So we're going to have to use these thinner ones as our connecting rods, I guess. Use pins and axles to secure but allow free movement. Well, we can't do that because there's an axle connector in there. So I think we might be stuck here as well. I think we might be stuck here. I don't think there's anything that we can do after this because it doesn't give us specifics on key parts. I know what I could do. to make it work. But I'm trying to not think about that, because I'm trying to come into this with a I have no idea what I'm doing mindset. So like, yeah, I know exactly how I could get this thing to work, but I'm going solely on what it is telling me to use. And right now, we're stuck. So we have to end with this, which looks more like an engine than last time, but still doesn't feature anything that moves or has any function. Let's read through everything else that it has that it's telling me to do in the instructions. Step 5, install the crank handle. On one end of the crankshaft, add a gear and a handle. Use a large gear or knob to rotate the crankshaft by hand. Step 6, test the engine. Slowly turn the crankshaft using the handle. Watch the pistons rise and fall. You've built a Lego engine. Optional additions. Okay. Add a timing gear system to simulate a camshaft. Use power functions or a Lego motor to automate movement. Add a fan, radiator, or flywheel for realism. Want visual instructions? Let me know and I can generate or find a visual Lego guide or schematic to help walk you through the steps with images. I am not going to answer that question. We're going off of one submission here. I do not think the visual guide would be anyway. Actually, let's ask for a visual guide. So one thing, this is technically cheating because it took a human to make all of these pictures, which are reference points, but it does give part numbers. Reading through this looks like you might actually be able to get something from this. Keep alignment precise. Add more cylinders for realism, but be cautious of increased friction. Automate with Lego power functions or even pneumatics for higher speed or pneumatic builds. Okay, so ChatGPT was a little bit better than Gemini, but as you can see, still not complete in its engine-ness. So that's about all that we can get from there, because it left out key components like how to build the connecting rod. Without that, can't get anywhere else because it didn't tell us how to do it. So that's where ChatGPT ends. Alright, finally, Microsoft Copilot. Okay. So right off the bat, it gives me multiple videos on tutorials from KF Plus and a couple others here. This is absolutely building a Lego engine is a fun and rewarding project that blends creativity with mechanical curiosity. Here's a step-by-step guide to help you get started, along with some excellent video tutorials that walk you through the process visually. That part doesn't count, we can't use that obviously. So step 1 is gather your materials. You'll need Lego bricks of various sizes, Lego Technic pieces like gears, axles, and connectors, a piston element, it can be custom built, okay, rubber balloon or syringe for vacuum power, and a base plate for stability. Well, luckily, we got plenty of them. So we have a base plate. The Lego Vacuum Engine tutorial, High Performance, provides a detailed breakdown of all the parts you'll need, including how to build each component like the piston, valve, crankshaft, and flywheel. Of course, we can't use a video tutorial, we're using just what the AI generates. Step 2 is build the base. Start with a sturdy Lego base plate. We have one right here. Construct a frame using bricks to support the engine components. This is the first time that it specifies to use bricks instead of beams or lift arms. So we're getting into the real Lego engine building here by using regular bricks. Now it doesn't specify what shape. So what I'm actually going to do is I'm just going to stack it up like this, kind of make this base kind of look a little something like that. Perfect. Ensure the base is stable enough to handle moving parts. Seems stable. Assemble the cylinder and piston. Use vertical bricks to form a cylinder. Seems like it's a very common theme, being very vague with the part usage. It just says vertical bricks, so I'm going to use some of these wall panel pieces. Not panel pieces, just wall pieces. We're using all kinds of different colors, even transparent pink. But these are vertical bricks. So use vertical bricks to form a cylinder. well, we can't exactly make it round, but we'll settle for square, I guess. It also doesn't say how big we need it to be. So I think I'm gonna go for a rectangle, so probably a 2x4 piston in this case. Insert a piston that fits snugly but can move freely. Seal the top of the cylinder to prevent air leaks. This How to Make the Simplest LEGO Vacuum Engine Working video explains that the physics behind how the piston moves using air pressure and shows a very beginner-friendly build. Again, we can't use that. So it doesn't specify how we connect it, but it does say to seal off the top, so we're gonna do that, I guess. We're gonna use some 2x6 plates for this. It also does not specify to leave a hole for any kind of valve. It also doesn't specify what kind of engine we're making. Are we making a vacuum engine or making a model engine? Does not say, so we will not know until we end. And it is connected. Now, of course, we're gonna have to use a 2x4 plate for the piston here. Add the crankshaft and valve system. Connect the piston to a crankshaft using LEGO axles and connectors. Build a valve system to control airflow. This is key for engine motion. Use gears to synchronize movement. Watch LEGO Engines tutorial for a variety of engine types and how to integrate crankshaft and valve systems effectively. Okay, I'm pretty sure this video is, yeah, it's this amazing video, by the way, of how to make small scale engines for like speed champion cars. Not for vacuum engines. It doesn't even use crankshaft and valve systems in it, so I don't know why it linked to that video of all of them, but so added the crankshaft and valve system, so connect the piston to a crankshaft. It does not specify how to build a crankshaft. It says LEGO axles and connectors, but it does not specify what kind of connectors. This is a continuing theme I'm noticing. So now it says just connect it to a crankshaft. Lift arms here. It does not specify this. If we have to, we won't count this. And then it does say use connectors. Alright. So we have some resemblance of an engine here, though it's not the best. Something. It says to build a valve system. So this one, it definitely should have specified what kind of valve system. SVS. We doing poppets. It doesn't tell us. This is not something that we can just guess or ask it like, oh, what kind of valve system. This is something that would actually take a lot of work to get things lined up and everything. A crankshaft is something that's simple and is basically unchanged, varying between different types of engines. But the valves, that's something that's very different depending on what type of engine you're building. So we're just not going to be able to make that, unfortunately. Step 5 is install the throttle and flywheel. Add a throttle body to regulate airflow, and attach a flywheel to maintain momentum and smooth operation. So a flywheel, it's got wheel in the name, a wheel. So we're going to use a wheel here. There's that. We are going to modify the base to fit the engine and test and troubleshoot. Use a syringe or balloon to create vacuum pressure. Observe piston movement and adjust for smooth operation. Check for air leaks and friction points. We have something that more resembles an engine. It actually has, moving bits and whatnot, but still a lot left out. We technically didn't even know what a crankshaft was because it didn't tell us how to build it, and it didn't tell us how to build a valve or anything like that. This one, again, is very, very, very vague. I would say Copilot did better out of all of them, really. So far, anyway. So far. Maybe we can get more specific. One of the other ones will do better. But so far, Copilot's winning. Okay, now I want to ask the AIs to help me build a butterfly vacuum engine. For those that don't know what that is, a butterfly vacuum engine is a type of vacuum engine that doesn't have a dedicated valve. Instead, it uses the piston itself that tilts within the cylinder as a valve. Alright, so now I'm going to ask Gemini how to build a butterfly vacuum engine because I don't actually know how to build one. This is the perfect test to see if AI will be able to tell me how to build one because I've never done it before, so I don't know what makes them work and what doesn't. Okay, so while the idea of a Lego butterfly vacuum engine is intriguing, there are no official Lego sets or widely known instructions for building such a device. A butterfly vacuum engine is a complex, real-world mechanical device that operates on a vacuum principle, and replicating it with Lego bricks in a functional way is not feasible. Oh man. Okay. Lego bricks are designed for building static models, and while some sets include motors, gears, and other moving parts, they are not engineered to withstand the forces and pressures required to create a functional vacuum engine. The tolerance between Lego bricks would prevent a proper seal, and the parts themselves would not be strong enough to handle the forces involved. So AI is basically telling us that every vacuum engine you've ever built is just not real. Oh man, okay. If you're interested in building with Lego and want to explore engineering principles, here are some alternative ideas. 1. Lego Technic sets. 2. Simple machines with Legos. And 3. Lego Mindstorms or Spike Prime. So Gemini basically just said, that's not possible. Oh man. So Gemini basically gave up. It didn't even try. And it said that vacuum engines are possible. So, yeah. Well, I guess we'll move on to ChatGPT now. Okay, let's move on to ChatGPT. Okay, so off of the failure of Gemini in this test, let's see if ChatGPT can do any better. Again, if it leaves any kind of links or videos, we're not going to click on those. We're going just off of what the AI tells us. Okay. Building a Lego butterfly vacuum engine is a fascinating project that can help you explore principles of pneumatics and mechanical design. While it's a somewhat complex build, I'll break it down into manageable steps. We'll assume you have basic Lego building pieces and some pneumatic components like pumps and valves, as well as a Lego motor. We don't need that for a butterfly engine. We don't need valves either. Okay, so I don't know how to build a butterfly engine, but I do understand their basic operation. They don't use valves, and they use some kind of tilting piston mechanism that relieves pressure within. I really don't know exactly how they work. All I know is I've been told they're some of the simplest engines that you can build out of Lego that actually run, and that they have like one moving part, and that's the piston. So we don't need anything pneumatic either, so I don't know what it's talking about here. So materials you'll need: Lego pieces, various Lego Technic beams, Technic wheels or discs for the butterfly's wings. It thinks I want an engine that looks like a butterfly. What? Pneumatic components, if available, like pneumatic cylinders, tubes, and a pump. Again, we don't need that for our vacuum engine, but whatever. Lego motor and battery box, which is optional. It's optional for automated parts. Lego valves, optional for better control of pneumatic flow. Lego base plates or a sturdy platform. Okay, well, we already have plenty of base plates. Here, I'll use this really old, thick one. 2 non-Lego components, optional. Pneumatic tubing and connectors, if you don't have a full Lego pneumatic set. A vacuum pump. You can build this using Lego pieces as well. Has anybody ever built a vacuum pump? I'm sure they have. Step 1, build the base. Begin by creating a sturdy foundation using a large Lego base plate. Oh, this is large enough. Attach several support beams across the base to form a solid frame. This will hold the rest of the components in place. It doesn't say bricks. We gotta use Technic beams. It says go across. So we're doing just that. Step 2, design the butterfly wings. Use Technic wheels or circular Lego pieces to create the butterfly's wings. You'll need to attach them to rotating axles for movement. This is going to be interesting. Let's grab some wheels. Okay, I have these 2 large wheels here, and it says rotating axles. This is such a funny interpretation. Like, butterfly engine is a well-known thing in the community. The fact that the AI doesn't know that so funny. Use the LEGO Technic connectors to build the structure of the butterfly wings. The wings should be able to move independently. Make sure they attach to the axles with a gear system for smooth operation. Okay. Well. This is where interpretation gets really fun. Because I can make this thing look as stupid as I want it to, because it's just giving me not good instructions. Okay, so what I'm going to do here is I'm going to do this. We're going to have a wheel there. Wheel there. Oh my goodness. And then we're going to grab some gears. It also doesn't say how we're going to support this. So we're just going to use some axles on here with some of these connectors. These connectors have stud holders on the bottom. So we can do this. This is very much looking like a butterfly right now. Good job, ChatGPT, good job. And then it just says connect it with gears. And there we go. This is wonderful. Yep. This is something, alright. But technically it's what it told me to do, so. The wings should have a hollow cavity inside. I should have read ahead. The wings should have a hollow cavity inside them for air to flow through, simulating the vacuum effect. Well, they are hollow, so we are currently simulating the vacuum effect, according to AI. This is simulating the vacuum effect. Very cool, very cool. You learn something new every day. Alright, step 3. Build the vacuum chamber. Create a sealed chamber using LEGO beams and plates that can generate a vacuum. Attach pneumatic cylinders to this chamber, ensuring they're tightly connected. This is going to be interesting. So we have to use beams, not bricks, beams, to build this chamber. How I'm going to do that, I don't know. And it also said to use plates. I actually have no idea what I'm going to do for this. How do you make a vacuum chamber with beams and plates? That is truly a mystery. If somebody can figure it out, please let me know. Because I'm not going to be able to. Okay, so we have here our chamber. It's actually hollow inside, so I don't know if you can even see that. It's hollow inside a little bit. So theoretically could do something and attach pneumatic cylinders to this chamber. Luckily I also have some of those, though they're not the ones that you would use to build an engine with. I've been asked a couple times. They're these long ones. I've tried multiple times and did not go according to plan. So because it doesn't specify how to attach said pneumatic cylinders to this chamber. What am I doing? Okay. Install pneumatic valves on the sides of the chamber to control airflow in and out. Once again, does not specify how to attach them. So there's the valve attached. Very nice. Position the vacuum pump, either Lego or a small external one, so it can suck air into the chamber, creating the vacuum effect. I thought we created the vacuum effect by spinning the wheels. Come on, ChatGPT, figure it out. Connect the wings of the butterfly to the pneumatic cylinders. The wings should be able to flap up and down based on the air pressure inside the chamber. So we're taking our rotational thing we made and we're basically getting rid of the rotation. Okay. How on earth am I going to do this? Okay. Let's just... I don't know if we're attaching this to somewhere else or what. I guess let's attach it to... Let's connect it to the ground, I guess. So now... Okay. Well, we might actually have some movement here. Of course, not by the vacuum effect, but you know what I mean. so now when we spin this, it should actually... Oh, no, we just broke it. Well, so much for that. I see what it needs. It needs to be designed by a human, and not me. That cylinder's gone. We don't need that extra cylinder. It's not doing anything anyway. It said cylinders, plural. So we have to have at least 2. If we hold this down and spin it, it doesn't work. As we rotate it, it will now actuate the piston. Yay! We have successfully made the vacuum effect using this. It actually kind of does look like some kind of steam engine or something. That's interesting. Anyway, attach pneumatic hoses to the valves, making sure you can regulate airflow. The idea is that the vacuum will pull the wings down and pressure from the cylinder will push them up. Now, it did not say to attach the hoses anywhere else other than to the valve. So, of course, we're not going to. Alright, build the control system. Use Lego gears and axles to control the rotation of the vacuum chamber's internal components. What internal components? You could use a Lego motor for automated movement or manually control the flapping with a crank system. That's what we're going to do. We're not putting a motor on this stupid thing. Position the motor, yada yada yada. If you want better control, whatever. Final assembly. Double check all connections to ensure the pneumatic tubes are properly sealed to avoid air leaks. Test the movement of the wings by activating the vacuum pump and adjusting the valves. The wings should flap when air is drawn into the cylinder and open when the vacuum is released. Tweak the wing structure for optimal movement. You may need to adjust the weight or tension of the pneumatic cylinders to get the wings to move smoothly. It says test the butterfly vacuum engine. Run the engine using the vacuum pump and observe how the wings respond. The butterfly should flap its wings up and down like an insect when the vacuum system is engaged. Fine-tune the pneumatic valves to get the movement just right. Experiment with different configurations of wing shapes, pneumatic pressure, and valve placement to optimize performance. This is so stupid. If you want to automate the vacuum system, you can use a Lego motor and connect it to a crank system that controls the opening and closing of pneumatic valves. Okay. The butterfly's wings can be made with flexible pieces to create a more realistic flapping effect. If you're using Lego pneumatics, consider using a Lego air pump to create the necessary airflow for the vacuum engine. If you don't have Lego pneumatic pieces, you can simulate the vacuum with motorized fans or even a small vacuum pump. Okay. Clearly, ChatGPT has no idea what it's doing. It thinks a butterfly vacuum engine is a vacuum engine that works and looks like a butterfly. That's amazing. And I mean, this creation is amazing too. I mean, obviously this is an amazing creation, right? So I guess let's move on to Copilot now. Alright, finally, let's move on to Copilot. Alright, so after seeing what ChatGPT created, let's see if Copilot can do any better. So, building a Lego butterfly vacuum engine is a fun and beginner-friendly project that combines creativity with basic engineering. Here's a step-by-step guide to help you get started. Okay. Materials you'll need. Lego Technic bricks, including axles, connectors, and beams. So no bricks again, okay? A rubber balloon or flexible membrane. I don't know why, but Copilot really likes balloons. Lego piston and cylinder components, or build your own using bricks. Okay, that's what we're gonna do. We're gonna do that. Flywheel can be made from Lego wheels or gears. A vacuum source, like a vacuum cleaner or syringe pump. I like the idea of the vacuum cleaner a little bit more than a syringe pump, but whatever. Rubber bands or seals to prevent air leaks. Okay, so step-by-step instructions. Build the cylinder and piston. Create a cylindrical chamber using Lego bricks. A cylindrical chamber using Lego bricks. A cylindrical chamber using Lego bricks. Okay. There's no hope for AI. There's just no hope. So we're required to build a cylindrical chamber using Lego bricks. Well, the only cylindrical chamber you can make with bricks by using macaroni bricks. So that's what we're gonna do. Again, does not specify how big it needs to be, doesn't specify how tall it needs to be. It just says, build a cylindrical chamber. So we are going to follow those instructions. I have a feeling this is going to be even crazier than ChatGPT's answer, but also that's going to be really crazy if it's going to be crazier than ChatGPT, so insert a piston that fits snugly but can move freely. Well, the only thing that we have that can fit inside would be a 2x2 technic, or a 2x2 brick, not a technic brick, just a 2x2 brick, round brick that fits smoothly. Attach a balloon or flexible membrane to one end of the cylinder to act as the vacuum seal. I don't have a balloon. Are you kidding me? Like, the one thing I don't have right now is a balloon. Alright, you know what? Paper counts as a membrane, right? That's what we're using. Paper. It says to just attach it. So, just use a rubber band. It did say we're going to need some. Did it? Might have been the last one, I don't remember. No, it was this one. Good enough. Alright, well, it's not going to create a seal anyway because of the studs, but at least it's on. Seal the system. Use rubber bands or extra Lego pieces to ensure the piston chamber is airtight. Make sure the balloon is tightly secured to prevent leaks. It's not a balloon, it's going to leak no matter what I do. So, yeah. Add the flywheel. Connect the flywheel to the piston's output axle. It has no output axle. We're just gonna attach it straight to the... Alright, this is actually gonna be interesting. This is actually gonna be interesting. So it said we can use gears. So I have a 40-tooth gear here. And it said to the piston's output axle. It never specified to use a crankshaft or a connecting rod. So I literally just attached it to the piston. So, yeah. Alright, create the butterfly mechanism. Let's see what the butterfly mechanism is. In this engine type, the piston itself acts as the valve. Hey! It did it. It actually knows what a butterfly engine does. Design the piston so that it rocks slightly or shifts position to allow air movement during operation. That is the worst explanation I've ever seen. Okay, why would it tell me to design the piston in a certain way after it tells me to insert the piston? Like, that was step one. This should be step one. Design the piston so it rocks slightly. Well, that means we just need to make it thinner. Obviously. Yeah, now it rocks back and forth. Perfect. Connect to a vacuum source. Attach the back of the engine to a vacuum cleaner hose or syringe pump. Ensure the connection is tight and secure. Test the engine. Spin the flywheel gently to start the motion. That's not gonna work. But I guess I'll give it a shot. We'll hook up the back, wherever the back of the engine is, to a vacuum and we'll see what happens. What's gonna happen? Place your guess in the comments. Where's the back? I guess the paper would be the back? I don't know. Let's see what happens. Wow. What was I expecting? Oh my goodness. Well, and then it offers me a visual guide. You can check out this YouTube tutorial for a demonstration and build walkthrough. There's also a detailed breakdown on the LEGO Engines wiki that explains how the butterfly piston works. Hey, LEGO Engine wiki. Looky there, it does. It definitely does tell you how they work. Well, that's a cool mention, thank you, Copilot, for mentioning that. And then what's this YouTube tutorial? I'm guessing this is KF Plus's video. Elmer and Kevin. Interesting. Okay, well, it's an interesting choice of video, I will say that. But yeah, this is definitely not a butterfly vacuum engine. So Well, interesting outcome. I will say that. Okay, it's safe to say that AI has quite a bit of work to do in LEGO engines. So it looks like we're safe from AI invading our space. For now.
Anyways, thank you for watching, and I'll see you in the next one.